Okay, this fucking crazy paper, Situational Awareness, is doing the rounds of the internet at the moment. I created a recap. Important to know before the recap. So what is AGI and what is superintelligence? As I've shared in some previous essays, binary definitions and terms like intelligence and AGI, they're misleading. It's better to think of these things as existing on a spectrum. Narrow at one end of the spectrum and broad or more general at the other. So currently AI is toward the narrow end of the spectrum. It's good at summarizing existing scientific theories, not so good at formulating new ideas or designing novel experiments to test them. Not yet, anyway. So most smart people agree that at some point in the nearest future, AI is going to move towards and beyond human level general intelligence on that spectrum. So it's no longer the if, but the when that is most interesting. The when and the how. Some people predict that we're on track for this to happen very soon. Others think we're a long way off. If the very soon camp is right, i.e. we move further along the spectrum to vastly smarter than human general AI within the decade, things are going to get fucking wild. So situational awareness. Situational awareness is this paper. It presents the case for how and why we're likely to progress toward the superintelligence end of the spectrum faster than most people are expecting. So the predictions in the paper are insane. There's many bottlenecks and arguments for why progress to AGI and beyond won't happen within the decade, but viewed through the lens of the enormous economic and geopolitical forces likely to soon be involved, which is what are explained in the paper, it seems at the least plausible that it's going to happen very soon, and it's definitely worth considering. So this is my attempt at condensing and simplifying the paper. I reworded and mashed a bunch of stuff together, so please read the original for full context. There's 4 main parts to the paper. Chapter 1 is from current AI to AGI, which is talking about the or order of magnitude of progress. Chapter 2 from AGI to superintelligence, which is all about the intelligence explosion. Chapter 3, which is broken up into a few different parts, talks about the challenges along the way, the $1 trillion cluster, security and alignment. And chapter 4 is the project, or the AGI arms race. So let's look at chapter 1, from current AI to AGI's of progress. So the first point, predicting AGI by 2027, orders of magnitude. So the major claim for the first chapter and for the entire paper is that following the current rate of progress, we could realistically have AGI by 2027. Progress toward AGI should be viewed in orders of magnitude, which is a 10x improvement per year. Compute and algorithmic progress. Next point, you basically need 2 things to continue progress along the intelligence spectrum. 1, you need increased compute, and the increased compute helps to train and run the models. And 2, you need algorithmic improvements. These are the improvements in the way that the AI learns and performs. And over the last decade, we've had roughly an order of magnitude of increase in combined compute and algorithmic improvements every year. So 0.5 in algorithmic improvements, 0.5 in compute, or increased compute. And if this continues, we'll almost certainly move along that intelligence spectrum very quickly. Next point is about the uncertainties, bottlenecks, and the data wall. The data wall is the example. So Leopold in the paper hedges everything by emphasizing there's steep error bars in both directions, meaning it's possible we move slower along the spectrum due to a number of variables like the data wall or bottlenecks, but it's also possible that we move faster. So the data wall, for example, is talking about models being because the current models are trained on vast amounts of internet data, we're going to run out of internet to train the models on. In fact, we've almost already run out of internet. On the other side of this, there's some very smart people and very well resourced companies that are working on novel ways to get around the problem, like the creation of quality synthetic data. Next part was about unhobblings, which you can see here in the top of the graph. Unhobblings are like AI cheat codes, so they're not part of the order of magnitude progress. They're also, it's the ability to unlock latent abilities in the model which require no extra compute or cost. So it appears there's still a bunch of uneasy unlocks or unhobblings, which could not only keep us on track, but turbocharge algorithmic improvements. Next point was about increasing divergence from leading AI labs. So there's now increasing incentives for leading labs to not share information with the outside world. This is only going to intensify, which will likely create a divergence between how leading companies approach creating AGI and how the rest of us muggles make sense of what is happening behind the curtains. Next point is about jobs and the automated worker. So you can say goodbye to your job. Most people envision an advanced chatbot version of ChatGPT like what we have now, but what we're likely going to see very soon is a more advanced remote co-worker who will basically start sending many white-collar workers on permanent vacation. Okay, on to the next chapter, which was from AGI to superintelligence. This is about the intelligence explosion. The best way I've explained the intelligence explosion is to imagine you read one textbook this year on a particular subject. Next year you read 10 textbooks and your ability to understand and conceptualize the idea improves 10x. That's 2 years. By year 10, you're effectively reading, writing, and comprehending the equivalent of 10 billion textbooks in a single year. This is understanding and synthesizing information in every field. It's hard for us to conceptualize this kind of exponential growth. It's a very crude way to understand what we might be in for. So right now, half of the progress in AI, which we've already discussed, comes from the algorithmic improvements. It's being pushed forward by hundreds of human AI researchers. These are biological meat monkeys. Imagine if we had millions of AI researchers working around the clock. No workplace diversity meetings, onboardings, or toilet breaks. It seems possible that we will reach the advanced AI remote worker in this time. Next point is to expect a 10x advanced researcher by 2028. So this is the same thing. Whether or not you agree with the specific timelines, you have to confront the possibility that we'll have some form of vastly smarter than human intelligence, superintelligence, within the decade. So overall, there's going to be limitations on both the compute and algorithmic progress, but we can't rule out an intelligence explosion kicking off before 2027. Expect the progress to be slow, expect challenges, but realistically also expect by 26-27 we'll have automated engineers. By 27-28 we'll have automated researchers, and that will lead to 10x advanced researchers by 28-29. These are potential predictions, but once we have the automated AI researcher, the intelligence explosion can realistically kick off. Next part was about 100 years of progress compressed into less than a decade. So when we get this 10x researcher, we're going to rapidly expand research and development in almost every field. Think a compression of 100 years into less than a decade. From not imagining it possible for a human to fly, to landing a man on the moon, to ballistic missiles and drones, compressed into a few years. The next part was about solving robotics. A lot of people think you need robotics to be able to advance AI. Robotics is gnarly. But once we have the AI remote worker, we can basically compress a decade worth of remote research into less than a year. So this would be the conservative end. We would then more than likely be able to solve the gnarly problem of robotics, and then robots are officially flipping your burgers, changing nappies, and building their own robot factories. So on to chapter 3. So chapter 3 was split into a few different sections. I've broken it down to understand into racing to the $1 trillion cluster, 2, protecting the weights, lab secrets and espionage, and then alignment and super alignment. So the first part, racing to the $1 trillion cluster. Big part of the essay is about this $1 trillion cluster idea, or $1 trillion investment. So this is the money and energy required to get us to AGI within the decade. This is a disturbing number. It'll be $1 trillion worth of research into training and launching advanced AI systems. $1 trillion. This is a lot more the money than the cost of the International Space Station, Large Hadron Collider, and every Olympics ever hosted combined. Perhaps more disturbing than this amount is the fact that the wheels are already in motion. So the biggest, highest earning companies in the world are now more or less fully committed to building AGI. It's imaginable that we could make this happen within the decade, the $1 trillion investment. That is, earlier in the year, a lot of people thought that when Sam Altman, who is the CEO of OpenAI, they thought he was crazy for throwing around a $7 trillion required figure to advance AI to its full potential. These numbers are seeming less crazy by the week. Next part is about the revenue. I think this is really important. It's possible that we're going to see $100 billion revenue from just AI by 2026 for a single company, meaning that AI will contribute a third of the revenue of Microsoft, Facebook, Google, or OpenAI, for example. 2026 does seem a tad ambitious, but it actually feels plausible considering how aggressively each of the companies are pursuing and pushing AI forward. In addition to the growing revenue from AI, a remote drop-in worker that we discussed earlier would potentially send tens of thousands of white-collar jobs on permanent vacation, but it's also going to free up trillions of dollars of salary expenditure for these companies. $1 trillion would be roughly 3% of US GDP, and there's plenty of examples throughout history of economies mobilizing much larger chunks of cash to direct towards important things. Another limitation discussed was about energy targets and chip manufacturing. In a similar way, it also seems plausible that we'll hit the required energy targets. So a bit of napkin math is 20% of US energy production toward AGI. Energy companies are starting to get excited already. Both the demand side and the supply side seem they could see support toward the above trajectory. Google, Amazon, and Microsoft are investing in data centers, which are located near abundant energy sources. Though it's going to be challenging, we'll have to redesign energy policies and explore some large-scale energy requirements. Some people talk about concerns with chips, but the chips are less concerning. It seems that chips will be less of a constraint than energy. Having chip manufacturing onshore will also be less important than having the data centers onshore. The implications for companies like Nvidia and TSMC are huge. Hope you already placed your long orders on those stocks. Next part is about security. So he talks a lot about weights and the secrets. You can think of the weights in current LLMs, if you don't understand them, as like a digital cookbook, storing all of the learned knowledge of the models. Billions of recipes developed, refined, and ready for upload. If you have the book, you basically have all the recipes, and you have the ability to easily upload the model and all the work that went into training it. So currently, the weights of models like ChatGPT-4 aren't that important because if you upload this current cookbook, it's not going to give you the power to create a biological weapon of mass destruction. But at some point, when we get further along the intelligence spectrum, it will have this capacity. So for now, what are important are these secrets, which are held in the heads of a small number of AI researchers, supposedly casually being discussed at San Francisco dinner parties. These are secrets which could plausibly jumpstart a number of questionably intentioned entities on the path to superintelligence. Other countries, maybe the CCP is being implied here, Middle East. And then it's also discussed a lot about state-level espionage. Espionage is being severely underestimated, and soon there's going to be immense forces attempting to steal the secrets, and soon the weights. And many already think the labs have been compromised and infiltrated by competing state intelligence agencies and the likes of the CCP, Chinese Communist Party. The next part is about alignment and superalignment. So alignment is the idea that we'll be able to align artificial intelligence with human values, guardrails, if you will, to ensure the development of artificial intelligence remains safe, reliable, and committed to the best interests of its feeble creators, aka us. Next part was about alignment being possible, but also very hard to get right. So the author believes that alignment is ultimately possible, but there's two major caveats: the required evolution of the guardrails as the intelligence progresses, and the concerning rate of change, the rapid rate of change that we're going through now. Initially, it's going to be relatively easy to set alignment guardrails, but it feels very likely that within a year or so, we're going to be attempting to align systems far smarter than they are now, at which point it's going to become increasingly difficult to set appropriate guardrails. Then he talks a lot about interpretability. I've put an image here of some recent research by Anthropic on interpretability. So there's a bunch of exciting research happening at the moment in the field of interpretability. This is basically attempting to reverse engineer and understand the process and patterns responsible for creating outputs. As an example, this paper that I put here, mapping the mind of a large language model, the Anthropic team were able to find repeatable patterns, or in brain speak, similar neurons firing when discussing related concepts. So this is what we're talking about, the neural nets that are running under the hood of these large language models. So when looking near a feature, this is a quote from the paper, when looking near a feature related to the concept of inner conflict, we find features related to relationship breakups, conflicting allegiances, logical inconsistencies, as well as the phrase catch-22. This is basically the Anthropic team trying to reverse engineer the black box, not understanding how the models work at the moment. And then the last point is about needing new and innovative forms of interpretability and alignment. This is a super alignment problem. Intense. So while the author acknowledges the exciting work and the type of interpretability, he reflects that fully reverse engineering increasingly intelligent systems, the black box gets more confusing, is going to leave us basically up shit creek without a paddle. We're going to need to employ more innovative forms of interpretability, ultimately relying on the systems themselves, so creating new AI systems to help us understand how they work and ensure alignment that way. Okay, next chapter is all about the project. This is definitely the most terrifying part of the paper. This is the AGI arms race. First point on the AI arms race, imagine compressing a century's worth of military technology or technological advancements in military into it within a decade, maybe less. It'll be like sending an army of fighter jets, automatic assault rifles, and precision-guided missiles to meet an opposing force of horseback cavalry with bolt-action rifles. This is the potential military advantage given to whichever team is able to first harness AGI. So currently the US and the Allied forces are ahead in this race to superintelligence. For how long, we don't know. When national security forces understand this is the next point, it's going to become a matter of national security. So the author shares that while he's not an advocate of heavy government oversight, and he also wishes the technology was used for the betterment of society, it seems almost inevitable that artificial intelligence will become a matter of national security, and then the push towards AGI will look less like an open technology startup race and more like a lockdown relationship between Lockheed Martin, the military, the government, and a select one or two highly regulated AI labs, pushing the development of new and highly effective WMDs, weapons of mass destruction, unfortunately. Next point was about open source being a bit of a fairy tale. So there's an idea at the moment that there's going to be some decentralized open source models. There already are some fantastic ones, but it seems less likely that these will be the frontier. So open source development of artificial intelligence might play a lesser role in developing lagging variations, use cases, and models, but in terms of cutting edge development and the main race to AGI, it's a bit of a fairy tale. And the Manhattan Project is continually discussed. So the whole situation is eerily reminiscent of the Manhattan Project, which is, was a massive, secretive, and resource-intensive effort to develop nuclear weapons during World War II. And then just on some final notes here, this took a bit longer than I was hoping. The 2030s are going to be insane. So before the end of the decade, we'll likely have superintelligence. In the 2030s, if we make it, will be fucking wild. And the AI realist camp. So there's a heated debate going on at the moment if you're on Twitter that tends to split the audience into one of two camps. At one extreme end, you have those that believe AI should be stopped at all costs as it's going to result in the inevitable extinction of the human species. Or some people that think it's not even worth stopping because it's too late. And then at the other end, the other extreme, you have those who believe we should be accelerating at all costs toward the creation of super intelligent AGI, where we're going to seamlessly merge with machine and project our consciousness out into the vast and unexplored cosmos. The author reflects that much of the argument on either side of the debate is either obsolete or harmful. He proposes a new camp, AI realists, or maybe this camp already exists, and they believe that A, superintelligence is a matter of national security, B, America must lead the race, and C, we better not fuck it up. And just the last point was, what he's laid out above is what he thinks is the single most likely scenario. At this point, you might think he is crazy, and these ideas have developed in his own head, he's changed his mind. But the ideas which initially started as abstract jokes are starting to feel very real to those in Silicon Valley who are actually creating the thing.